the topic. Because it's a scientific conference, we have to have some theory. So the topic is about safety assessment methods using the risk assessment method. So the safety requirement is something that pedestrian infrastructure has to meet. And so this is the road risk method, where we have risk assessment and risk treatment. Different scales. It's an area, network, section, point, pedestrian crossing methods. Reactive, proactive, predictive. This is more for the operations, not so much as regards pedestrians, but reactive and proactive ones, yes, very much so. Risk management levels, strategic, and then tactical and operational. Types of risk: societal, general, normalized, individual, group risk. Risk measures, direct and indirect. I'll give you some examples later on. Risk estimation measures and the methods for that. So we have forecasting, estimating, and classes of risk, which is very low, low, medium, high, and very high with the respective colors. And risk acceptance, and that's already included in one of the ordinances, looking at road classification, but we will be promoting and pushing for that so that other regulations include that as well. So risk measures, we have general ones, normalized ones, like number of injuries, and for example, when we have exposure and when it comes to vehicles, we have miles traveled, an indicator which we don't have for pedestrians. We did try and encourage road authorities to measure that as well, but it's not very likely. And then we have integrated measures that include exposure and the likelihood and consequences of the risk. So reactive methods. In the guidelines that talk about the design of pedestrian infrastructure, our classification is based on existing data. It's 10 years. Even if it's a shorter period, we will calculate it over 10 years. And so accident density lower than 1 per kilometer per 10 years, that's very low risk, but anything above 3, this is very high risk. Reactive methods. These methods are based on accident data, but they can be referred or related to different areas, such as a county or region or a network, or shorter, longer sections. And here's an example of a classification, a regional classification. The measure is deaths and serious injuries over a period of 3 years. And you can see where the risks are the highest on the map. And we applied a similar classification to assess risk on regional roads or local authority roads. This was commissioned by the General Secretariat, and this is available from their website. And those black sections, these are high-risk sections, but this is individual risk. What is the risk I'm exposed to when I use these roads? And that's the risk of death or injury. Proactive methods build on other information. It's not just accidents, it's also speed or traffic volume. And here's a simplified method for classifying risk on those sections of roads for specific speeds. Anything above 70, then that's not a good road for a pedestrian to be on. And speeds below 20, that's residential areas, that's where the risk is negligible. Proactive methods, and we did this as part of our work for the lighting guidelines. We used the risk score method, and here's our proposal to assess risk based on the likelihood of being at risk. And this is assessed based on the length of the pedestrian crossing, the speed of pedestrians, and how much time they spend on a crossing. So that's one group, and the other group is the likelihood of an accident depending on pedestrian and vehicular traffic. I used the work of Professor Olszewski and other international sources. And then the third group, depending on the speed square. Right. And this is the adjustment coefficient. Polish literature says that for grade separated crossings, it's 10% probability that there will be an accident when they will not use a footbridge, and then a raised zebra-type crossing, a very high rate, but just a designated zebra crossing has the risk between 0.8 to 1.2. And when you have two different sets of traffic lights, that makes things even worse for pedestrians. And we have a similar classification for sections of roads. Speed is the next factor. We use the reference speed, which is the 85th percentile, which is the speed limit times, well, because obviously if we cannot measure it, then at least we have to estimate this. And so we will use a study we conducted before in built-up and non-built-up areas, whether there is a speed camera or not. If there is a speed camera, then it's 1, and it's 1.5 on national roads. And this is equivalent pedestrian traffic volume. And we look at the structure, adults, seniors, and people with disabilities. And then we have an equivalent volume of vehicular traffic, so trucks, that's higher risk, not so much for motorcycles. And we have classification of risk to identify risk levels. And these are the 5 classes that I mentioned. Below 10 points, that's negligible. Above 100, very high risk. And using this, we can develop a ranking of the most dangerous crossings or road sections, and then we can identify the risk level. And then we develop the acceptability rules. So very low risk is negligible, low and medium is tolerated, high and very high not tolerated. So what does it all mean? If it's unacceptable, this means that the risk for pedestrians is very high. Just as Tomasz Mackun said, at 0.1, these are the crossings in Warsaw. And so when we plan our design, such sites, we shouldn't allow this to happen. This is a design error, and it shouldn't be happening. If the level is tolerated and it's existing, then we have to apply some treatment there. such as changing the speed limit. But we should also, if it's still at design stage, then we have to change that to a safer option. So you can use the risk calculation model for this. And if the risk level is acceptable, then no change is required, but still we should monitor the site occasionally. And so we use this method for pedestrian crossings, for road sections, for pedestrian infrastructure, for selecting pedestrian crossings, and for checking lighting on pedestrian crossings. Like, let's say we have 100. This is the volume, and this is 1,000 on the right-hand side. And then reference speed versus traffic volume. So on some non-urban roads, it's 70 kilometers per hour with a volume of 5,000 vehicles, then we're off the scale. If it's 2,000, then we're off the scale as well. And that difference is crossing with an asylum, and this one is without one, so having an asylum or this island helps a lot. And obviously, if it's a national road, then a zebra crossing wouldn't work at all. Thank you.